Examples 4, 5, and 6 for the 3-2 Part 1 notes are a continuation of example 3, so we're still using that same image where we have now written in our coordinates for Q, R, and S, which are reflections of point P across the y-axis, origin, and x-axis. Example 4 asks us to find the sine of an angle whose terminal ray intersects the circle at point S. Now, remember that we have a radius of r, so we're going to be using point S in this problem. Well, point S has coordinates x, negative y. So when we use an x or a y value, it will be those coordinates, the coordinates of point S. So, the sine of any angle, it doesn't matter what angle we're talking about, is always the horizontal displacement over the radius, or y over r. For point S, that means we are going to be plugging in the y coordinate of point S, which is really negative y, and then the radius is still r. So our answer here would be negative y over r would be the sine of the angle whose terminal ray intersects the circle at point S. In example 5, we are asked to find the cosine of an angle whose terminal side runs through point Q. So again, when we use x or y, we're going to use the coordinates of point Q for those values. The cosine of any angle is always the horizontal displacement over the distance from the origin, or x over r. And again, since we're using the angle that passes through point Q, that x will be the x coordinate of point Q. So our answer here would be negative x over r. Finally, in example 6, we're asked to find the tangent of a circle that intersects the circle at point R. So again, we're going to pull our coordinates of point R, which are negative x, negative y, and we're going to use those for our x and y values in this particular problem. So when we find the tangent of any angle, that is equal to the slope of the terminal side, which again is going to be your horizontal displacement over your, your vertical displacement over your horizontal displacement, or y over x. So again, we're going to be plugging in those two values from point R. The x coordinate will go on the bottom, the y coordinate will go on the top. Now notice that in this case, both of those are negative. So we have negative y divided by negative x, and a negative divided by a negative, those negatives would cancel, leaving us with the ratio y over x. Thank you very much for your time on examples 4, 5, and 6.